All right, today we're doing the test for two variances. And a couple of things for the two sample variance test. What I want to do is look at how you find critical values first. So to find critical values for this distribution, it's a new distribution to us. It's called the F distribution. Okay, and the F distribution is a family of curves distribution, similar to like T, for instance. But one thing that's quite different about it is to use your charts, you need to look at the right alpha, and we have what's called DFN, and we also have what's called DFE, okay? So because it's a looking in the book chart type of thing, you have to go to the correct alpha. So if it's a two-tailed test, you're going to have to divide alpha in two and go to that table. But if it's one-tailed, we'll just go to the alpha, kind of like the t-distribution. DFN and DFD, what those stand for are degrees of freedom for the numerator and degrees of freedom for the denominator, okay? Now, we have to be very specific on this. Because there's two samples, we have N1 and we also have N2, okay? So both of these degrees of freedom are going to be N minus 1. But the question is, which sample goes where, okay? So I'm going to call this, instead of just labeling this generic N1 or N2, I'm going to call this LV for larger variance, okay? So whichever sample has the larger variance, that's going to be your degrees of freedom for the numerator, okay? Whatever that sample size was, minus 1. Whichever sample has the smaller variance, so I'm just going to call this guy SV, for smaller variance, that's going to be the coordinating N that you put for DFD, okay? And then, of course, alpha, if it's one-tailed, just use alpha. But if it's two-tailed, then you're going to use alpha for 2. Let's just do a couple of examples. So, first case. All I want to do is find the correct critical value. Okay, so example 1. I'm going to give you some stuff, and I just want to know what is the correct F critical value. Okay? So here we go. We have S1 squared is 37. We're given that N1 is 14. We're given that S2 squared is 89. And we're also given that N2 is 25. And we're given that this is a right-tailed test. Okay, so this is all the information given. And we want to find the critical value. I also need to know what alpha is, yeah? 0.01. Okay, so here's the first thing that we do. It's a right-tailed test, so we're going to use all of alpha, okay? So we're going to use alpha's 0.01, so we're going to open up the back of our book, and we're going to go to the correct alpha table that is 0.01. So based on my book that I have, this is on page 789, alpha's 0.01, okay? Then the next thing I have to do is I have one sample, so these guys are together, right? S1 and N1. One sample has a variance of 37, and one sample has a variance of 89, okay? So the larger variance sample, according to this labeling, is N2, okay? And that is 25. So my degrees of freedom for the numerator is going to be 24 because this is the sample that had the larger variance. Does everybody see that? So I'm going to do 0.01. This is going to be 24. And then degrees of freedom for the denominator is going to be this one. 14 minus 1 is 13. Okay, so across the top, you have degrees of freedom of the numerator. And our degrees of freedom of the numerator is 24. And luckily it's in there. Okay, so just go right to 24. If it's not in there, you go to the closest smaller value, just like we've always been doing. And then degrees of freedom for the denominator is 13. So you have to match this up with 13. Does everybody see that? And if you bring those two intersected together, you get 3.59 for your critical value. All right? And honestly, this is 90% of the problem for today, just getting the right critical value, because the test value is actually really, really simple. It's easier than most test values that we've ever had to do. So make sure that you can walk through all these steps that I took 5 minutes to do and get that critical value, because obviously if you can't get that, you don't get it right.
Can you go over that last step one more time?
Just getting that 3.59?
Yeah.
Yeah. So were you okay with alpha's 0.01, DFN's 24, and DFD's 13?
Mm-hmm.
Okay, so across the top, we want to go to DFN, which is 24, so find 24 across the top. And then across the side, you want to go down to DFD, which is 13, and then you just have to bring those numbers together. So go to the column that's 24, go to the row that's 13, and you should be able to read 3.59. Okay? And that's your critical one. Let's try another one. So I'll leave these up, because we always have to go through the same 3 steps here. Well, let's try example 2, just finding another critical value. Make sure we can get this right. Okay, example 2. We have a two-tailed test. We have alpha's 0.05 with the two-tailed test. We have S1 squared is 232. We have N1 is 30. We have S2 squared is 387. And we have N2 is 46. Okay, great. All I want to do is find the correct critical value. Okay, so let's start. It's a two-tailed test, and alpha is 0.05. So if we're going to go and look at one tail, what alpha would we actually use? 0.02. Okay? So anytime you're using the F distribution and it's two-tailed, you have to split it in 2. Okay? So you're going to use alpha's 0.025. Now again, we have one variance is 232 and one variance is 387. 387 is clearly the higher variance. So that's going to be the sample size that goes with DFN. This guy's 46. Okay? So n minus 1 is 45. The larger variance. That's why I put LV here. Don't just put a 1 or 2. Let's just make sure you know that that's corresponding to the larger variance. Then this is 30, so the smaller variance is 29. And it's n. Okay? All right, so hopefully in this example, these might not be on there, and I did that on purpose. So we go to the closest smaller value. So 0.025 in my book is on page 790. I'm looking for DFN of 45 across the top. 45 is not on there. So I go to the closest smaller value, which is 40. Okay? So we're going to go to 40. Then DFD is 29. Is 29 in there?
Yes.
Yeah, it's in there. So bring 29 together with 40, and you get a critical value of 2.03. So your CV is 2.03. There's a lot of things that can go wrong in getting that critical value. So just make sure you follow these 3 steps exactly, and you'll be fine. Okay? All right, let's do a test. So obviously, this is a 2-sample variance test. So in the problem, it should ask about comparing 2 variances. You know how to do the critical value, and I need to give you the test value formula. And lucky for you, it's a really easy test value. So here's your test value formula for today. F equals S squared over S squared. All right, now one of these is from one sample variance, and one of these is from the other sample variance, okay? So I want you to put the LV, the larger one, in the top. Okay? So the higher variance in the top divided by the lower variance in the bottom. And that's it. It's just S squared over S squared. Okay? Pretty easy test value. Great, let's do an example. All right, a consumer claims there is no difference in the variances of the number of hours that 2 company batteries will last. Okay. So consumer claims, this is example 1. There's no difference in variance of hours that 2 company batteries will last. 2 company batteries will last. Okay, great, that's the claim. Then they give some statistics to you. 10 batteries from company X had a variance of 24. 10 batteries from company Y had a variance of 40. Okay, so we have, let's just do 2 samples here. So we had company A and company B, and they said 10, a sample of 10 for this one had a variance of 24, and this one had a variance of 40. Okay, from company A and company B. And at alpha equals 0.10, test the claim. Okay, and again, the claim is there's no difference in the variance of hours that 2 company batteries will last. We have 2 samples, and we're comparing the variance. Okay, it should hopefully be a good clue that that's today's material, testing the difference between 2 variances. Okay? Okay, great, let's do it. Step 1, HOH1. Well, today we're doing variance. So your hypotheses should be based on sigma squared, or the variance, okay? So I'm going to let A be 1 and B be 2, or I guess you could just call it A and B, that's fine too. So I'm going to say sigma A squared versus sigma B squared. You guys could use 1 and 2 or A and B, it doesn't matter. And then what equal sign or not equal sign or inequality am I going to use for there's no difference in the hours? Equals, right? So there's no difference in the variance of the hours versus there is a difference. So I'm going to put in parentheses, this is the claim of no difference. That they're equal, okay? Okay, then the whole time today so far we spent in class, find the correct critical value. So go ahead, go to work, find the correct critical value. Step 2, what is the critical value? Kind of made it nice for you because they both have the same sample size, right? So DFN and DFD, it's really hard to get that wrong. But you want to go to the right alpha. This is a 2-tailed test. Alpha's 0.01, so you guys want to go to 0.05. And it's really nice that they both have the same sample size, so you know DFN has to be 9, you know DFD also has to be 9. Okay? And if you could be so kind as to look up that critical value for me, and let me also do it so we can check each other. Are you getting 3.18? 3.18 the critical value? Great. Okay, so I'm going to kind of make a little makeshift F distribution, and here's 3.18, and here's my critical value. Okay? When we're doing a 2-tailed test, we're only looking at one alpha side, so you're just going to look at the right side. Okay? In fact, all these problems, you're just going to look at the right value. So please put that in your notes. You're just looking at the right side. Great. Step 3 has one of the easiest test values you're ever going to have. F equals whichever variance is higher divided by whichever variance is lower. In this case, 40 is higher. So it's 40 divided by 24. 40 divided by 24, you can take that to your calculator. It's not going to be 3 something. You're getting about 1.6 repeated.
Yeah.
So that's clearly to the left. Great. So far so good. Step 4. It's not in the critical region, so I do not reject HO. And step 5. If I don't reject HO, I'm going with that there's no difference. So yeah, we agree. we agree with the claim. There is no difference in the variance of the hours of these company batteries will last. Okay? Any questions on this problem?
So why did you use population variance in the HOH1 instead of S?
HOH1 is always based on population parameters. So we always have mu here, or sigma here, or p here. And then the sample stuff is always when you're tackling your test value. That's what the sample data comes from.
All with the roundness.
One thing to be on the lookout for is sometimes they'll just give you s instead of s squared. So you'll just have to square that when you get to the test value, right? So if they said s was 24 and s was 40, then this test value would be 40 squared over 24 squared, right? You have to know when to square and when not to square. But other than that, all of these problems are pretty much the same, okay? Pretty easy, as long as you can get the right critical value. Okay, that is the end of the material on your next exam. So it's review time. What is on this test? Everything. But how do you attack it? Okay, so the first thing that happens is you read the problem, okay? And if in the problem it says confidence interval, then it has to be this. There's only 2 confidence interval problems on this exam. One of them was a confidence interval for a proportion, and the other was a confidence interval for variance and standard deviation, okay? So if the problem has the word confidence interval, or the words, you know it has to be one of these, okay? So it's a confidence interval for a proportion. So we're looking at, is it talking about percentages or proportions? Or is it talking about variances or standard deviations? Okay? And that's all there is to it. So if I read a problem that says, oh, such and such confidence interval, I know it has to be one of these. If it's talking about proportions, then I go to my notes and I look up everything I need for confidence interval for proportion. If it's talking about variance or standard deviation, I go to the other one. Okay? This is a z distribution. This is a chi-square distribution. So you need to have that on your sheet of notes, like what type of distribution and how do I do it. Okay? That's it for confidence intervals. Okay, then, if it's not a confidence interval, it's a hypothesis test, right? So now I'm reading through the problem, and the next main thing that I have to determine, is it one sample or is it 2? Okay? And that should be relatively easy too. Is it one sample or is it 2 samples? Okay, if it's one sample, then we have a couple of things that can be, right? So I'm reading through it. It's a one sample hypothesis test. Is it talking about the mean or average? Okay? If the question is about mean or average, then we have the potential for a z-test for the mean, or a t-test for the mean. And there's only one deciding factor that tells me if it's a z-test for the mean or a t-test for the mean. And what is that factor?
Sigma.
If you know sigma. Does it say in the problem, the population standard deviation is known to be 7? Great, that's a z-test, okay? So sigma known. Otherwise, the problem looks identical, but it doesn't tell you sigma. It just says, hey, these guys had a mean of 10 and the standard deviation was 8. Okay? If it just says that, then that's S. That's not sigma. Okay? So sigma not known. Okay? And that'll tell you if it's a Z distribution or T distribution. Great. Once I know those, the other problem should be pretty easy. Is it talking about proportion? Or is it talking about variance and standard deviation? Okay, so we have to be really clear on what the problem is asking and what it's talking about. If it's a proportion, then great. It's a z-test for a proportion. If it's a test for variance or standard deviation, that's a chi-squared test, right? Okay? So this is kind of a semi-flow chart for how we're doing this, right? It's a confidence interval. It has to be one of these. It's a one-sample hypothesis test. Great. Are they asking about the mean or average? Because then it's a z-test or a t-test. Is it asking about proportion? It's a z-test for proportion. Is it asking about variance or standard deviation? It's a chi-squared test for variance or standard deviation. Okay? Okay, so that should handle all one-sample hypothesis tests and the only confidence intervals we have on there. Moving to the last chapter, which is a biggie. Now the question is, okay, I'm doing a hypothesis test. Clearly there's two samples. So it's a two-sample hypothesis test. Okay. Is it talking about the mean or average? If so, it's a z-test or a t-test. How do I know if it's a z-test or t-test? Same thing over here. Are sigmas known, sigma 1 and 2, or are they not known? Okay? So you have z-test for the mean, or you have a t-test for the mean. And here you need to know sigma 1 and sigma 2 are known. These population standard deviations are known, or they're not. So if sigma 1 and sigma 2 are not known, it's a t-test. Okay? And then unfortunately for us, the flowchart doesn't stop there, because what happens when we do the t-test for this chapter?
It's dependent and independent.
Oh, well, yeah, that's true too, but let's say it's independent, okay? So this is independent. You had, are variances assumed equal or not? Right? So go back. We always assume variances are not equal, unless in the problem it states assume variances are equal, okay? And these have different test values, right? One was kind of uglier than the other one, and they have different degrees of freedom. You have to have all of these in your notes, okay? So I have a two-sample test. It's a test for the mean or average. Do I know sigma 1 and 2? It's a z-test. Do I not know sigma 1 and 2? It's a t-test, okay? Now, are they assuming the variances are equal or not? Because those are different test value formulas, okay? And these are for independent samples. It's going to be clear when you do a dependent sample because it's a before and after, or it's some direct relation, some matched pairs, okay? All right, so we just did two tests here. We did z-test and t-test. Great, let's move to 3. Dependent sample. T-test. This should be obvious because it should be a before and after situation, or a matched pairs situation, right? Husband, wife, twin 1, twin 2. Okay, we're dealing with the same sample and doing something with a before and after, okay? So it should be fairly obvious when you read through a problem that, okay, this is a before and after or a matched pairs situation, and that's going to be a dependent t-test. All right, then the fourth possibility is it's a two-sample test for proportions. It doesn't say anything about mean or standard deviation. It's just proportion, 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 right? This percent went to Disneyland. This percent went to Disney World. Is there a difference? Two-sample test for proportion, okay? And this is a z-test. We need to know what these distributions are. All right, and then I just have what left?
What we just did.
What we just did, right? F-test for variance or standard deviation. So the problem is talking about the variance or standard deviation with two samples. That's what we just did today. It's F-tests for variance or standard deviation. Okay? You guys need to be super, super, super clear and really, really awesome at figuring out what test it is, because that should be the easy part, and then just going through the test, okay? You need to have on this sheet of paper all of these tests, what test value it is, how to do the critical value, you know, what distribution to utilize. You just have it written down and ready to go. Any questions on anything that I've done? This test is really hard, okay, so please study. Okay,